We practiced solving square root equations. These are the steps to solve. You might need to pause for a moment and get these. First, you get the square root by itself. I usually say you isolate the square root. Then you would square both sides because to square something is opposite of taking the square root. Then you continue to solve for the variable. If you have a quadratic equation, you can use factoring, which is a little quick hint here. For factoring, you would need, let me start here. You need an equation in this form: ax squared plus bx plus c equals 0. And you would need factors of a times c, that when you add them, you get a sum of b. You can flip back to your summary, your explanation of factoring. You could also use quadratic formula if you're more comfortable with that. Quadratic formula is this. Please use parentheses when you substitute. That C is really weird, but it's just a C. Okay. And check your solutions. We're looking to see if you have extraneous solutions, which those are extra. That happens when you isolate your square root and it's equal to a negative number. That won't ever work out. You could just stop right there. It's no solution. Or if you substitute your solution to check into the original equation and the equation is false, then that solution would be considered extraneous. It's extra. I have 4 examples to work with you, and we'll follow the rules that we just set for ourselves. I want to remind you of a kind of a good little tip we used when we were solving absolute value, and that is to take the if you have a lot of moving parts, you have a lot of things to look at, and you need to simplify the problem with you to get it isolated. You could take out the square root expression and replace it with the variable, and then write the rest of the equation around it. And we would need to write or isolate E, the expression. So this isn't an especially complicated problem, but sometimes they are, and this may be helpful for you. Either way, you would subtract 4 to solve. If you write it as E, that would look like this. E equals 3. And then you could substitute the expression back in. So it would look like this. To know whether we need to continue solving or if this is a problem with no solution, this is isolated now. I need to make sure this number is positive, and it is. So we go on to the next step, which is square both sides. When you square a square root, those are inverse operations. So you just get what's underneath the radical. We need to square 3. Don't multiply by 2. I see that error very often. And don't just bring the 3 down. It's 3 times itself twice. That's what squared is. And then we continue solving for the variable. X equals 7. It takes very little time for you to check your problems, check your solutions, I mean. So I recommend that you always check, so that you can take comfort before you move on that what you just did was right. To check, you substitute what you found for X and the original equation in place of x. And we want to know, is this equal to 7? So you can put the left side into the calculator, or I'll just do it by hand. The numbers aren't large or unfamiliar. Square root 9 plus 4. Square root of 9 is 3 plus 4. 3 plus 4 is 7. So this is a good solution. Next. I have an expression that is isolated. Square root equals positive number. So I can solve this. I square both sides of the equation. The squared and the square root are inverse of each other. So I have 2x over 4. This is equal to, oops, I just did it. 4, 2 squared. And a fraction is a division problem. So this is the same as saying 2x divided by 4. The inverse of division is multiplication. So I multiply both sides of the equation by the denominator. Now I'm multiplying by 4 and dividing by 4. So that reduces 2x equals 16. Divide by 2 to solve for x. And x is 8. Before I move on, I plan to check my solution. So here I will do 2 times 8 divided by 4. Is this equal to 2? I hope. Square root of 16 over 4 is square root of 4, which is 2. So this is a good solution. Example 3. This here, I know this looks strange. These are considered isolated. I have square root expression equals square root expression. So I have isolated expressions. I just square both sides. Squaring is inverse of square root. So I remove the radical. And I'm left with 2m minus 6 equals 3m minus 14. And I solve for m. We get m is 8. And I check my work. Sometimes when you check these with radicals, what's underneath is negative, and so your calculator will give you an error. It's not a real solution, it's an imaginary solution. So what I will do with these is I will leave the radicals on when I check. So I'll just simplify what's underneath and make sure that we're taking the square root of the same number. Now, 2 times 8 minus 6, which is 16 minus 6. So to the left, I have square root of 10. I need to know, is that equal to what happens on the right side? 3 times 8 minus 14. So square root 24 minus 14. This is also square root of 10. So it's a good answer. Works out. Last one. This problem, my expression is isolated. So I square both sides. And I take the radical off of the left. 5x plus 6. This is equal to x squared. Since I have x squared, I have a quadratic equation. So as explained with the steps for solving, I need to have an equation in the form ax squared plus bx plus c equals 0. A standard form equation. I'm going to move the left side over to the right side so that my x squared is positive. It really doesn't matter if x squared is positive or not, but I like it better if it is, so I'm going this way. You are welcome to choose to move the x squared to the left. So there's nothing left on the left. The way I rearranged this is equal to x squared minus 5x minus 6. I'm going to choose factoring. You could choose quadratic formula. I need to have, well, for this problem, a is 1, b is -5, c is 6, or -6, sorry. So I need factors of a times c, which is -6. And if I add, I get a sum of b, which is -5. To multiply and get -6, I can multiply -2 times 6, 2 times 3, 2 times -3, -1 times 6, or 1 times -6. And I need the sums of these. I need the sum to be -5. I do this one, I get 1, and this sum is -1. This sum is 5. The sum is -5. 1 minus 6 is -5. So those are the factors I'll use. +1, -6. 0 equals x plus 1 times x minus 6. I need to set each of these factors equal to 0 to solve for x. So if x plus 1 equals 0, that happens when x is -1, and x minus 6 is 0, which happens when x is 6. I need to check both of my answers. So I'll substitute into the original equation. I have square root of 5 times -1 plus 6. I want to know if that's equal to -1. I substitute x twice. To the left, I have square root of -5 plus 6, which is square root of 1. Square root of 1 is 1, so it's not equal to -1. My x is -1. This is an extraneous solution. Because when I substitute and check, it doesn't work out. Let's check x equals 6. Is square root 5 times 6 plus 6 equal to 6? This is square root of 30 plus 6, so square root 36. This is equal to 6, so this one works out. I only have one solution for that problem. There are 6 problems in your class notes. It says more examples. These are worked out in the class notes. We work them in groups at the whiteboard, and then you have a practice assignment.